Hey, how you doing?
Hi,
All right, pick community college.
That's right.
Well, there's one plugged in. I think that's not here, I don't know. No, these lights there, so. Should be able to put it in mode.
Is it high converter?
How you doing?
Actually, if you want to, let me do that.
Just because I showed up?
That would be easier.
Scan everyone's badge real quick. Exactly.
I didn't know we were doing it.
See, just in everything.
Not everybody's been scanning.
I know.
Hey, Chris, can we get a copy of that?
We can
The
provide.
attendance?
Yeah.
All right. While he's doing that, I'll just make sure one more time. If you're here for PCI compliance, it's actually in a different room. If you're here for hyperconvergence data center infrastructure for mid-size and smaller organizations, this is this presentation here. So we had a few folks who weren't quite sure before. Chris, you ready for us to start?
Yes, sir.
Well, it is still morning, so good morning, everybody. My name is Kevin Greenwood. I'm with Scale Computing, and this is my colleague Shane Weinbrecht. I have been with Scale for coming up on 8 years now, and in my current role, I manage our partnerships with our channel organizations, so resellers and distributors of Scale Computing. I live in Durham, and Shane is one of our senior technical engineers. He is a virtualization expert on several certifications, and so we're here to talk with you about hyperconvergence for small to mid-sized organizations, and specifically details around Scale Computing's HC3 products. So I'll start by maybe setting the stage as to a typical existing data center, okay? So let's think about that for a second. And I'm going to put this in terms of complexity. So I want you to think about the data center you guys have. You probably have some host servers, and I'm going to guess Dell, HP, Lenovo, one of those brands is pretty typical that we find. If you've done some virtualization, most folks have, some at least. You're probably running VMware. A smaller subset of folks tend to be running Hyper-V, but VMware is pretty popular out there. If you've done any high availability for your environment, you've likely got a SAN in place, or at least a NAS. So you've got some sort of a shared storage system in place. We generally find that that's Dell, HP, EMC, NetApp, one of those vendors out there.
No, they changed.
You probably have some sort of a backup environment. That could be Unitrends, that could be backup exec. There's several different ones out there, obviously. You probably have some sort of a performance management system in place for your virtual environment. That might be a SolarWinds system or something similar to that. You may have implemented some sort of a disaster recovery service as well too, whether that's a backup to cloud or failover to cloud capability. The point being that we take for granted the infrastructure requirements for a data center and the complexity that brings along without really even thinking about it, because it's just been ubiquitous throughout the last 10 plus years. And so it's a daily part of an IT administrator's life to manage all of these different vendors and different applications, et cetera. Most folks have not had the luxury of working in an IT environment where they got to design from scratch their environment. Most of us have taken on a new job or a new role, and we've inherited something that's already in place, and we've had to begin to make that work and add features and functionality to that. So, in fact, that might look a little bit like your data center, proverbially, if you will. So over time, you inherited something, you added something else to it, you had another challenge come up, you bolted another piece onto that, and that's kind of what you end up with, right? So it becomes a bit challenging to manage that type of an environment. So we at Scale Computing, most of us were IT administrators ourselves, and in founding the company, this was the challenge that we faced. Very similar probably to the challenges you guys face. And so we decided to step back from it all, really at a moment of frustration, decided to step back from it all and said, okay, we've developed technology before. If we were to really start with a clean sheet of paper, would the data center infrastructure that we designed as a purpose-built for virtualization, would it look anything like what we administer today? And the reality is there's a lot of moving parts, a lot of different vendors, a lot of stuff that's there because they got developed over time by different vendors and different entities, and it all ends up having to work together. So what if we just started over with a clean sheet of paper? So back to the complexity of the traditional infrastructure here. This probably looks very familiar. You've got host server 1, 2, 3. You've got an external virtualization management system. You've got shared storage. You've got all those cross-connected for redundant purposes. Above that, you've got your virtualization layer, etc. That's the typical environment that most organizations work with today. The reality is, with hyperconvergence, that does not have to be the complexity of the way things operate. So what we took was virtualization really likes to talk directly to disk. They like to talk to locally attached disks. They don't enjoy going across a storage protocol to an external system and mapping back and forth with all the attributes, etc. They like to talk directly to disk. But of course, if you do that, that's not highly available. So what Scale Computing built was a direct attached system that is highly available and has built-in intelligence for knowing how to allocate blocks of data to multiple locations simultaneously and gain a high availability out of that, so that you've got the ability for virtual machines to operate continually regardless of where their data blocks exist, whether they are local or whether they are on a different node within the cluster. So the concepts behind that are really what you see on the screen there. The ideas behind delivering a radically simplified architecture that is super easy to administer, to utilize, to set up and get running, but also to administer on an ongoing basis. Really the goal behind that was to allow administrators to focus on what they really are asked to focus on by their business operators, which is the applications that run the organization's activities. But we wanted to make sure that when we built this, everything was going to be highly available, fully fault tolerant, with redundancies throughout that, so that we know hardware breaks, right? It doesn't matter what vendor it is. Over time, something will break and go wrong. You need contingencies for that, so that everything, the applications and the data remain highly available, despite the fact you may have hardware challenges in that environment. We also felt strongly that it needed to be a scalable option, hence the name of our company, Scale Computing. And so what we offer is a node-based architecture. They look just like a rack mount server, but in fact they are a complete data center node. And so you start off with, could be just one, but you could, with a highly available config, you would have 3 of these. And then from that, you could add one at a time later on to scale your environment beyond that. We also felt strongly that Small to mid-sized organizations we knew are constrained with resources, with budgets, with time, and so we wanted to make sure that we had a very low cost of entry, and we had a model that would allow clients to mix and match any node of ours with any other node. So regardless of whether they started with the least expensive, smallest models that we offer, or the biggest, most capable ones that we offer, any of them can work with any of the other ones, right? So it gives you real granular scalability to that environment, and it also ensures that 3 months or 3 years down the line, whatever happens in your future, whether that's slow growth or overnight explosion of growth, you're able to accommodate that without having to be pushed by a vendor into a rip and replace configuration. That was for the small to mid-sized organizations. We felt like, and that was our experience being a small to mid-sized administrator. We felt like that was, those unplanned, unbudgeted, major upheavals really created problems. So we wanted to make sure we addressed that and covered a little bit about the affordability as well. So what we came up with is the scale computing architecture. Again, less day-to-day administrative responsibilities and time required there, and more nines of uptime. Shane will cover some of these as we jump into the product demo, et cetera. But the big takeaway is less time, less administrative overhead, simpler to use, et cetera. So I think that is my last slide before I turn it over to you.
So at Scale we think that actually showing the product is a little bit more compelling than just a whole bunch of slides, and you may agree with me on that? Yeah? Very good. So one technical prerequisite before we begin, can everybody open up a web browser and type in an IP address?
You got that skill? Everybody got that
We
skill?
can do that.
All right.
If you can do that, you can manage a Scale cluster. All right. I'm actually going to open up 3 other clusters here. I have a pretty robust lab environment, and there is a method to my madness, so give me a quick second here.
Wi-Fi's not on.
Oh, we need Wi-Fi.
Well, we could just ask about a web browser. So,
Where's the one reason? I didn't see it. Uh-oh.
Does everyone know how to connect to a wireless network?
I'll tell you what.
Let's see.
You get a failure.
And jack into your phone. There you go, reboot, right?
You know what? We're in the Marriott now.
Oh, right.
Embassy. You're in Embassy Suites.
that's true.
Okay, look for,
It's in the lower level.
iPhone KG. Is that one open?
Yes. Well, it's not open, but I've got the.
All right, good.
I'll be right back.
Okay, cool. Brief intermission.
Yep, sorry about that.
I didn't think about that moving that.
That's true. Moving different buildings.
So yeah, just to kind of preface, I'm going to open about 4 different clusters up, and I use them in different ways. I built in my lab environment what I like to think of an SMB type data center, where I have a production cluster, I have a test dev cluster, I have a backup archive cluster, and I have a DRVC cluster. And they're all used in those fashions, and I like to show people how they can kind of add to the different, you buy a production cluster now. If your budget year passes, you
Embassy.
DR, you can simply do
Password
that.
or username's Embassy,
Okay.
and the password is eSuites WS
Suites.
WS16. And I did that off of memory.
All right.
That was pretty good. Oh, maybe.
There we go. Do that. Just order. Just log in here real quick. Absolutely. Well, we probably need to do your VPN now, right?
Oh, yeah. Here, I'll get it.
Yeah. This is not my laptop. again, just one quick moment while I pull in my clusters here. Almost there. Okay, so what we're looking at here is the Scale user interface. Pretty straightforward. To get to it, all I did was open up my browser and type in an IP address. Username, password, standard, pretty much anything that you log into these days, right? First thing you're going to come to is our heads-up display. Across the top, you're going to see resource metrics aggregate across the cluster, so you can have a quick heads-up of how much CPU am I using, and this is cluster-wide. This isn't at the guest level. Below that, you're going to see a series of boxes. Each box here represents a node in the cluster, and then each bar here is a VM running on that particular node. So if I wanted to go to one of these nodes or one of these VMs, I can simply double-click it. It's going to open up another tab in my browser, and I will be able to log in and do whatever I need to do on that particular VM. Pretty straightforward. I can also go to, this is what we call the RAM view. It's kind of showing us how much RAM is allocated to each VM, and that's done per the amount of VM or the amount of RAM that's allocated to the VM is going to be represented in a larger bar. So some of these that you might have to mouse over here, it'll show you the different names of them. That just means they have a smaller RAM footprint. So 3-node cluster, the VM's running here. I can go to the disk view as well, and I can see, each of my disks, they're all healthy, they're all distributed. We distribute everything amongst the cluster. We do a process called wide striping for the data, which means that every single block of data that's on, say, drive 0 on node 1, it's going to have a mirror active copy on another node on another cluster. So if you lose a drive, your data's up, it's available. You're going to have that active copy. If you lose the entire node, your VMs will simply restart onto other nodes in the cluster automatically without any type of user intervention. So it's simply, it is a reboot process. I will be transparent about that. But you don't have to go in at 3 in the morning and start pushing buttons. That's the saving grace, if you will. Christmas Eve, the node fails. I'm sure you've all been in that situation at some point or another, birthdays or whatever it may be. Something happens, we auto-correct things and get things up and running. So, to kind of scroll down here to look at what that VM looks like, we'll just concentrate on that Shizra VM here. This is one of my VMs here. This is what we call a VM card. The VM card is a graphical representation of the virtual machine. It's very straightforward. It's going to give you the name, what the role is, what group it's in. I'll talk about some of these other things momentarily. And also it's going to have some metrics at the guest level. Again, at the top here, we're looking at aggregate across the cluster. And then we have guest level metrics as well. So kind of taking away that management monitoring piece by having it built into the system. If I drop down a button here, we can see the device view. It's kind of showing me how many cores I've allocated to this VM, how much RAM, what ISOs I have in the virtual CD-ROM drives, my system drive, my data drive, be it E, F, G, HI drive, whatever it may be. What's interesting about the way we use storage is it's object-based. You guys familiar with object-based storage? Anybody? So are you familiar with NFS, iSCSI, storage protocols? We remove that altogether. So you will not ever create an iSCSI target or one, an NFS share, or anything like that. We basically consume storage as needed. When I create a VM here in a moment, I'll kind of go through what that looks like. But what's interesting is, if we go back to the disk view again here, you're going to see that this is one of our hybrid clusters. It has spinning disk and SSD. So we have 3 SAS disks per node and then SSD. This is all one global namespace, one pool of storage. It's all working together, working in Unity, so all the I/O is distributed amongst all VMs. But what you can do, which is pretty interesting, is say this D drive on this particular VM is my database drive, for example. And I want that drive to have the highest tier of storage. So I'm going to pin that drive to SSD. I can edit that, pin that all the way to 11. Spinal tap reference, I'm not sure if you're familiar with that. We like to turn things to 11 at scale. So if I pin that drive to 11 on that guest, all I/O will go to our SSD tier. And on the other hand, if I want to go to my system drive, I can just leave it at normal flash priority, which means that we will start to use our heat mapping technology and apply our algorithms and say, okay, these blocks are hot, so we want them on SSD. These blocks are cold, so we're going to move them to spinning disk. And you can turn it off. So, moral of the story is that SSD is expensive. We all know that. But you can use it in a much more efficiently way by allocating on the per drive, per VM level, rather than having, lots of solutions have an SSD caching layer in front of a RAID set, or they have just simply, you have an SSD tier only, and the entire VM has to live on this SSD tier. These VMs live on this tier. We give you the flexibility to decide which workloads at the drive level to, again, more efficiently use your SSD tier. And then we can get into, now I'm going to go over this briefly, but I'll kind of show it in motion here in a bit. But snapshots, guest level snapshotting, replication, we have things like we can replicate from one cluster to the next for DR purposes, backup purposes, whatever you want, whatever the use case may be, and I'll touch on that here in a bit. But to get to this point where we're actually looking at a VM, obviously we have to create one. We have a plus sign, create VM, single pane glass pulls up. Keep it pretty generic right now. Let's call it test one. The descriptor could be, maybe this is an IIS dev server. I'm going to tag it to a group. By tagging it to a group, it's simply saying that this VM lives in my dev group. So when I want to go, if I'm thinking about, okay, where's that IIS dev server? Well, it's probably in my dev group. Whatever is meaningful to you. It could be HR, it could be finance, it could be whatever, tag that makes sense to you. So I tag it to my dev group. I'm going to choose which type of operating system, and your options will be Windows or other. Other would be Linux, right? Or another x86-based operating like FreeBSD or something like that. So we'll keep it at Windows. We're going to load a pair of drivers, very straightforward. They're VirtIO drivers. One's for the disk device, one's for the network device at the guest level. Basically what those do is allows the guest to have direct access to the hypervisor, thus improving performance at the guest level. So the name should not be a mystery. Then we're going to allocate some CPUs depending on the workload. Exchange, SQL, it could have 2 to 4, 6, 8 procs. Basic utility VM, 1 to 2 virtual CPUs, maybe 4 gigs of RAM. I'll throw 8 gigs of RAM at this particular VM. I'm an ex-admin, I guess if you call it, or former admin. Old Habits IR, 80 gig system drive, followed by 100 gig data drive. I can change these later if I want to, and all disk has been provisioned. So even though that I'm creating 180 gig or I'm allocating 80 gigs to this particular virtual machine, it's not going to start occupying those blocks until we start writing data to it. So you have the flexibility. I can easily go and say, I don't ever want to worry about my system drive filling up because of Windows updates. So I'm going to give it 500 gigs of space. When I go into Windows and start building that OS, I might only allocate or do it into a format on 100 gigs of it and have that extra 400 gig available to it later. But it still allows me to use, that space is still available for other workloads. You follow me? Okay. Here, choose the ISO. I'm not going to go through the entire process of building a 2012 RT server from scratch. I'm sure you're happy about that. But I hit the create button, and then we'll go to that dev group. And I have my test one VM card here. So I'm going to power this VM on because there's a piece of technology we haven't really talked about yet. And maybe I'll step back a couple, take a steps back as well. This is what we're looking at is called Hypercore. So Hypercore is our intellectual property. It is what makes HC3 HC3. It's our hypervisor, which is KVM, kernel-based virtual machine. It's an open source hypervisor. It's our storage subsystem that I talked about, that block device. We call that Scribe, Scale Computing, Reliable, Independent Block Engine, kind of an acronym filler, but that's what it is. And then we have another piece of technology that's unique that's called state machines. And state machines are actually, they're unique on with how we use them. State machines are in the wild. They're in your car, they're in airplanes, they're in vending machines, all sorts of things. And what they do in, let's say a car, for example, you have pressure valves, you have sensors, you have all kinds of different things that are monitored, right? Those are state machines monitoring that, you know, tire sensor or whatever it may be. I'm not a car guy, so the analogy may be off of it. But that state machine is looking at that pressure valve and it says, okay, if it goes above or below this certain threshold, then I'm going to send an alert to your car via check engine light. Check engine light comes on, you know you need to get to the mechanic in your car first, right? We applied a state machine to each node in the cluster. Then we made the state machine self-aware, or cluster-aware rather, and then applied about 2,000 different conditions to each state machine in each node in the cluster. So things like retransmit on backplanes, smart error rates on drives, all the way through the stack. You know, how many resources are available per node, per cluster. And an illustration of that is when I go to power this VM on, I can guarantee you it's going to start on this node right here, simply because that has the most available RAM. I didn't tell it to start there, it will simply populate there. And that's based off state machine technology. It hasn't proven wrong yet. There it is. And I could double click on that and we could watch paint dry, or we could go forward and look at other things. I prefer the latter, so. Now who all has like a DR site? Does everyone DR site in place? Okay. No problem, it's not totally uncommon. So I'm flipping over to another cluster here. It's a different family. This does not have SSD. It's just all spinning disk, and it's SATA as well. This is strictly tech dev for me. You know, it's kind of my sandbox, if you will. But the key thing is that regardless of what actual hardware you're using, the software is all the same across the platforms. So as Kevin was mentioning, you can get our entry level is HC1000. It's going to have the same software as the HC4000, which is our mothership. And they can all interoperate together. So, looking at this particular cluster, I'm going to go into our control center and pretty much talk about this machine right here. This is my one of my development machines that I use pretty often. I'm going to talk about guest level snapshots and what's interesting about those. So, if I go to the control center, and I can talk about some of this stuff a little bit later on too, but for now we'll just look at schedules. And I'm going to talk about this Ansible schedule here. So if I go to edit that Ansible schedule, you're going to see that I have set up my frequency of retention policies here. So I'm snapshotting every hour, keeping it for a day, doing a daily snapshot, keeping it for 2 weeks, so on and so forth. If I wanted to get more aggressive, say I'm doing some development testing or some development, and I want to be able to roll back to a very granular level, I can say, you know what, I'm going to take a snapshot every 15 minutes and keep this for 1 day. Or minutes here. I can type. Keep this for 1 day. So, say I'm doing, like I said, I'm implementing a new code revision or something like that. I can add that in there. It's say I don't want to do that because it's just too aggressive for what I do. But I could do that, and if there was an issue with something, I could simply go back to the last 15 minutes that the last snapshot was taken. What that kind of looks like, I'll just kind of pop up my snapshots on an hourly basis. So. Say I'm doing that exact same thing. I was doing some dev work. I started at 11 o'clock, 11:15, 11:30, something like that. If something happens, I can simply go back to my 11 a.m. snapshot, clone that. Within a couple seconds, I'll have an exact copy of that VM from 11 a.m. unchanged that I can jump in and start doing whatever work rather than having to retrace my steps, reverse engineer, figure out what I did wrong. You know, if I put a backslash where it should go to / or whatever may happen. Also works out really well in a scenario of, say, revision testing or patching, right? You know, you have SQL comes out with a new patch. You probably don't want to do that on a production machine. You can clone it, install the patch. You know, what you probably do in that type of scenario is, you know, edit the VLAN to maybe an isolated VLAN. You don't want 2 SQL servers with the same name IP address on the same VLAN, right? So update that, just pretend this is SQL. Start it up on an isolated VLAN, install the SQL patch or whatever operating system or whatever application you're updating, do the patch, do the testing, and prove that it worked. At that point in time, you can do a couple things. You can simply delete the clone and say, okay, yeah, this worked, I am comfortable, I can create a maintenance window for my production machine and apply that patch. Or you can go over here and disconnect the NIC on this VM, put this one on the production VLAN, and given that there might be a 1 to 2 minute or so window of downtime why that network switch makes or happens, but you're back up in production with a fully patched working system. So it kind of simplifies that process to a pretty high level in my opinion. So any questions? I know I've been talking quite a bit. Anything? No, pretty straightforward stuff. Cool. So along with guest level, along with scheduled snapshotting, we also have guest level replication that you can apply a schedule to. So the same VM, let's continue with the Ansible Dev VM here. And I'm going to go to another cluster, my DRBC cluster. You're going to see something pretty similar over here. This is a replica target. What's happening here is I set up replication from my test dev cluster to this cluster. I've applied that schedule snapshotting, and I can now go and clone from from those snapshots on this cluster. So in a catastrophic failure scenario, fire, flood, tornado, whatever may happen, my test dev cluster goes down. Let's call that production. That goes down, I can simply go over to my DR cluster and start spinning up VMs by this clone, just as I did before. Same process, clone, power on, I'm up and running. So in the case, I actually can go down here a little bit because I do use this DRBC cluster for my production cluster as well. Zeus is my domain controller. It is a real domain controller that runs in my lab environment, and I'm replicating that domain controller over here. So if my production cluster went down, I've actually double protected myself because I have a secondary DC run on this cluster as well. But say I didn't have this here, I could at least go clone my DC from the last time it did its replication, just as I did before, and power that on and be up and running. So things like Active Directory, things like Exchange, things like SQL, your ERP system, whatever it may be, things that you have to have running to keep the lights on, can be turned up very, very quickly simply by going to your secondary cluster and cloning and powering them on. Well, to take it a step further, you don't have to have a secondary cluster for that to happen. You could have a single node. We call it a snack. Well, I call it a snack at least. If I go to this cluster here, this is a single node. So thus snack, single node appliance configuration. It's just one node. There's no high availability. So if this were to go offline, that VM that's running on there would not restart anywhere because it has nowhere to restart on, right? But the key there is that I could get a three node production cluster and maybe a 1 node DR cluster, or maybe a backup target. This is more of a backup target for me in archive because with our snapshotting being so granular, we can simply go and use our snapshots as backup, really, effectively. So that makes it, it's kind of that whole piecemeal type of thing. You don't have to buy, 3, 4, 5. You can buy 3 here, 1 here. If you have distributed remote office, branch office type environments, if you have 5 locations. We have a customer in Iowa that has, I think, 24 sites, 1 mothership with 6 nodes, and then they have a single node all around all the other sites, and they cross-replicate back and forth, and everything's up and running and coming along like it should. Any questions? Yeah.
So if you have Oracle databases, in most cases people can say SQL, whatever.
Yeah, right.
Right, and that's fine, with both, right? But if you have a situation where you're using real application clusters,
Okay.
which you're familiar, it's basically running a database on multiple instances.
Right.
Being able to control which things one way or all this other kind of crap. If this goes down, there's the virtual IPs and it fails over and stuff like that.
Right.
This wouldn't impede that from working
No,
at all.
Not
This is
at all.
another node. I got this, I got that.
absolutely, yep,
So
absolutely.
for SQL databases that are very active and do a snapshot, okay? What does that mean in terms of database disk, logs, currently being used, not committed?
So for like
whatever?
transaction and flight type
Flight,
stuff?
potentially. You know.
Yeah, so, right now, we don't have VSS integration. That is something that it's right around the
That's
corner.
fine.
So when I talked about those VirtIO drivers earlier, for the disk and network, we're going to have a VSS VirtIO driver as well, which will take care of that. So for transactions in flight, you can enable VSS within SQL or do SQL log shipping or something like that. But that will be built into the product here within, I would say, the next, 3 months.
And that's fine.
Yeah.
You realize that you're fixing it.
Yeah, I mean,
Whatever.
Yeah, I mean, we're continually, the way we build out our product is kind of different than other companies. We don't throw a lot of features at the product. Originally, we didn't put a lot of features at it. High availability, obviously, the ability to live migrate, or vMotion as other people call it. We call it live migration. Just things like that. Those were 4 things that we knew that had to be in the product, right? That's what we put in the product. As time went on, like scheduled snapshot, that wasn't part of the product. That was something that our services team scripted on the back end. It got to be a very popular service, so we put in the product. Things like VSS integration. That wasn't high on the roadmap 2 years ago. It is now, so it's going in the product. So our method is more of, I listen to people in the field. I talk to people every single day in the field. We listen to our customers, and we even have an email list. It's productquestions@scalecomputing.com. Anybody can send any one of our customers or prospects can send
A
a
wish list is suggested.
Exactly.
User-driven.
Yeah, absolutely. And we listen and say, yeah, that's a great idea. We'll queue it up, and it may not happen tomorrow, but it will happen. So.
Hey Shane, you mentioned the Scale Legion as well too.
Yeah. That's so yeah. As far as kind of the whole community-driven type thing or customer-driven, I'm actually starting. We have our community called the Scale Legion, which is our user group community, which we're right now we're pretty active on the Mangalasi forums. Anybody heard of Mangalasi? Maybe we'll try to get a link out there. But the Scale Legion is a technology, and I kind of have a background in building technology communities based off VMware. In particular, I ran the Indianapolis VMware user group for about 5 years and grew that to a really, really big footprint. But anyway, so yeah, we're starting the Scale community. We kicked it off in April, I believe, and we're just going around doing user group meetings type things, and it's all about technology. It's all about getting to know different types of technology. And what's interesting about the way my approach to this group is that it's not so scale-centric. We're obviously, coming out there in this Scale Legion, but, my goal is to have a SQL MVP talk about database tuning, that type of stuff. Things that probably would run on the Scale cluster, but it's not, so focused that you have to be a Scale customer or anything like that. So I actually have, I think Q3, I'm not sure, I have to look at my board, but I might have a Q3 North Carolina event coming up, so you guys keep me posted. So there are a few other, how are we doing on time, Kevin?
It's 15 after, so we get another 15.
Oh, okay. I have 15 more minutes to board and pants off.
Not at all.
So, a couple things I really like to talk about. I think I covered the bases, right? I mean, we're highly available. It's easy to create VMs, the snapshots. I mean, the goal is just simplicity. What I can do now is concentrate on my applications. I don't have to worry about infrastructure so much. I can see that there's errors here. It's not an issue to me. I know that I can contact support. Support's going to log into the cluster and they're going to fix it. They're going to do it in a way that is pretty straightforward. You can see this. I went to the control center, remote support. What we do, and this, I'm a big fan of support, our support especially, because I've worked in the enterprise world. I worked for Adidas, I worked for IBM, and I know how it feels that, I manage large VMware farms. And something happens to an ESX farm, or a host or whatever it may be. You call VMware. They say, Oh, that's not our issue. What's your storage? Oh, I have a 3-part SAN. So what version of firmware is it on? It's on this version. Well, that doesn't work with this version of ESX. Like, okay, so you have to update this, you have to update this, or it could be insert X, you know, it's finger pointing, right? It's the nature of the game, not really saying anything bad about it, just, you know, just how it goes, it's cyclical. So what we've done is change that dramatically. We have one level of support, it's called Scale Care. That's it, period. It's not silver, bronze, gold, platinum, meaning that if, you know, really, if you have more money, you get better support. That's what that nets out to. We are stack owners as well. Everything from top to bottom and in between. We support the operating systems, we support the hypervisor, the storage layer, networking to the core, or from us to the core. You know, if you have other networking issues going on outside of Scale, then that's kind of on you. But from us to the core, we will support the networking. And the way that's done is simply by a phone call and email. You can open a case through your partner portal, whatever you want to do. We have an internal SLA to answer all of our calls within 120 seconds. It happens about, I'd say on average, 98% of the time. I see lots of hundreds, but you know, if I were to average out, you know, 8 weeks, it'd probably be 97, 98%, which is a pretty high number in my opinion. So you get through to somebody within 120 seconds. That individual is an engineer level. It's not help desk, and nothing against help desk. I cut my teeth on the help desk, but a help desk individual is going to ask you questions like, is the red light blinking? Is it turned on? You know, the plug-in, all those things that it's not, they're reading the script, it's not helping you. We don't do that. We simply say, what's your name? What's your company name? We type it in, you're pulled up in our system. We're going to ask you to put in a code. That code is a reverse SSH tunnel. You hit open connection. Once that connection is open, we can tunnel in at the root level. Keeping in mind that we're already monitoring about 2,000 different conditions on each node. We type a quick command called scget condition, and it'll show us anything that's in a set state, meaning that it's went above or below the threshold that's supposed to be at. And we can start diving into that. And maybe there's a million drop frames on Ethernet 0. We probably need to look at that right away, something like that, right? Or there's something wrong with drive 3 and node 2. So we can get to the problem very, very quickly and you know, resolve it, you know, right then, pretty straightforward. So I'm a fan of support 24/7, 365, next business day for replacement parts. And again, full stack owners, we can't point finger at anybody. That's all there is to it. We don't have the ability to. So I will say that, you know, higher end Microsoft issues, on the back end we'll work with Microsoft. We have a TS, I think it's called a TSA account. But yeah, we might bring in Microsoft on the back end, but we're not going to redirect you and say, oh no, sorry, Microsoft issue, you need to go talk to them. We don't play like that.
Thanks.
What's up?
You all right? Just a quick question.
Sure, oh yeah, please.
Licensing per cores and all the other nonsense you deal with, like, you know, SQL now is a core license, or words, things of that nature. And they don't like playing with VMs. You know, if you got a 12 node box, and you're carving it out into lots of VMs, sharing different aspects of lots of things, you still have a 12 core box. And that's what you get a license on, from Microsoft's perspective.
Yeah, and unfortunately there is nothing we can do about Microsoft.
And that's okay.
Yeah. I mean, I tell people that almost every day. It's like, if we could figure out a way around Microsoft licensing, we'd be in good shape. Well, we're in good shape anyways. But,
Oracle did it a little differently in terms of what Microsoft is calling containers over the years. I don't know that. But they, from open source and all the other stuff, they adopted zones, and zones was another one for containers.
Yeah.
You familiar?
Yeah, I mean, well, yeah, containers.
It's okay, sharing the kernel.
Right, yeah, containers is a new term, right? But
Well, sure.
it's been around like,
Nothing
you
is
know,
new.
Lexi and, you know, so it's
Yeah.
all that stuff, yeah.
All right, so now they, because they own the stack most of the time, they say, oh, you have this zone running and has 3, whatever it is, and you allocate this much storage, who cares about that, but it's all for them.
Right.
So if I got like 2 zones on Sun T4 Solaris box, whatever,
Right.
that's almost legacy now, isn't that
Right.
right? Isn't that stupid, except it's not, you know?
Right.
Okay, but you can license it and they would honor that.
Okay.
You know, which is kind of cool, so
Sure.
what the hell?
Yeah.
Excuse my language, you know?
Oh, no, I get it, yeah, I mean, I'm not a fan of Microsoft licensing. One thing
No,
I can say.
and it's okay.
Yeah. One thing I will say is there's no virtualization licensing associated with our product. You know, we use KVM. KVM is an open source hypervisor. It's what Red Hat Enterprise Virtualization uses. It's the platform that they can tell moved, what, 17,000 VMs from their vSphere environment over to a KVM environment. So that's a bonus. There's no, Essentials standard licensing or anything like that. And we don't charge for new features. So say we come out with a new feature, which we do somewhat regularly, you simply update it via firmware update. And the way that's done is really cool. This is actually going to probably be my last point, unless Kevin, I missed something. But if there was an update available, I would go to update, and it would give me a description of that update. There'd also be, there's no updates available. I'm at the latest version of firmware right now. But I would have the ability to apply update. I hit the apply update button right there. What will happen, I'll just kind of go to this VM here. What will happen is that, so we will initiate I'm doing this manual obviously. This is a live migration. But when you go to update, we're going to initiate a automatic live migration of that VM from this node over to another node in the cluster. Once all VMs have been evacuated from that node and there's no running VMs on it, we're going to start the update process. We're going to update the hypervisor bits. We're going to update, add any features, update the BIOS, whatever needs to be updated on that node, it's going to happen all at once. We then go to the next node. Do VMs over here, update that node. So it's called rolling updates. All the while your VMs are up and running the entire time. You can do it at 2 o'clock on a Tuesday. And furthermore, you don't have to go and look at hardware compatibility lists and make sure that different versions of firmware are going to work together, because we've already done it. We've already done all the revision testing on the back end. So you simply just hit the update button and go about your business. Whether you feel comfortable doing it at noon on a Tuesday, I think my admin in me would probably still not do that. I'd probably still do it on a Saturday, but you don't have to. So.
We even have clients who call in to support and have support sort of walk them through what that update is going to entail. And then some of them will say, well, hey, do you mind monitoring my update while it happens? And we can do that. So we're like an admin sitting there right beside you, virtually right beside you. And if anything comes up that you want to address or have questions about, they're right there. They can help.
Yeah, I could open up a tunnel and do SC update, version number, and update to the next version. I know there's newer code out there that's alpha, but then watch the update process through a command line. Just really something very straightforward. Yeah.
One more. I'm
Sure,
sorry.
please. No worries.
Yeah. I drank too much coffee. Yeah, whatever. Okay. So, in terms of like, hey, I got a product, or I got a runny nose, I need a tissue, or you mean you want a Kleenex? So owning the term, Coke, owning the term, whatever.
Right.
How, if companies are deeply in bed with not necessarily the right term, but utilizing VMware, and maybe future thinking to 2016, Windows Server, and hypervisor, when that's growing up because they learn. So, is there any initiative to say, if you are a VMware environment, am I off base, but it would really make sense to look at this from a cost perspective here?
Yeah, absolutely.
Okay, that's fine.
So, the majority of our customers, I would say, are have a VMware environment, right? Generally speaking, if we're talking to them at some stage, they are looking at doing a server refresh, which would be a SAN refresh as well. Probably extra licensing. Maybe they're adding a 4th host to a 3-host cluster. That 4th host increases the VMware licensing. So that's when they start looking at other places like like us, and we have competitors as well.
Oh, sure.
But yeah, that's valid right there. We have customers that use us in a hybrid fashion. I ran into scenarios where, and Kevin kind of mentioned, we kind of concentrate on the SMB space. We will go up a little bit into the lower end enterprise, but I'll get on a call with somebody and they'll tell me they have 8 ESX hosts, 1,500 VMs, a petabyte of storage. That's too big for us, but they have a project that fits that we fit. We only need 15 VMs on this. We don't have a lot of budget for it. It's like, all right, here, we can do this. That type of thing. A good example would be like, Oxford University, you know, they use us in their, what is it, their history department?
I'm less familiar with Oxford. I know
Okay.
like Auburn
Yeah,
University
Auburn,
in
yeah.
Alabama. So they've got a central IT who handles IT for most of the colleges within the university, but they do it on a chargeback basis, and they're not cheap. I mean, and the reason they're not cheap is they spent several $1 million investing in high-end infrastructure that they then, from a high-level IT department, decided we'll recoup our expenses by charging all the different colleges for the use of it. Well, some of the colleges have more powerful college presidents, and they said, no, we don't want, you know, we'll take your internet feed, but beyond that, we're going to do our own. And so they began to find us, and when the first one, which was the College of Mathematics and Physics, invested in Scale, they began to propagate that throughout. Now we've got 5 different colleges within Auburn all using Scale, and what they've done is one of the standard features of the product, I think Shane mentioned, is replication, failover, and fail back between different clusters. So what they've done is each department has bought a cluster that is sized just a little bit bigger than they need to accommodate providing replication space to their sister school, right? And each sister school has done the same thing. So they're treating each other as their own disaster recovery environment, and they're doing it at no cost, right? They've just, each one of them who's decided to buy Scale they've ended up with their built-in DR because their sister college has it as well too. So, and again, our model is all customers get all features. We don't charge for those, including future features. So as we come out with new functionality, that's gonna, you do an update, you get it, right? And that's, all customers get the update. So that's how that works. I've got one slide I do want to show to wrap it all up, and you can sit there, just alt tab for me if you will.
Okay. Well, I'll move over. I don't know that.
That's all right.
Yeah, I Windows.
All right. So, actually, 3 slides, sorry. So we do generally get questions like, well, you know, who's running this product? Would I know any of those customers? Believe it or not, there's a lot of firms, and here in North Carolina, we have several city governments and county governments running Scale, several sheriff's offices running Scale, some libraries running Scale. So, you know, if you're interested in this, I'm sure I could put you in touch with someone reasonably local to you who's already doing this and has migrated from another platform environment. We mentioned this specifically, but we do have tools that will migrate you from VMware or Hyper-V or whatever virtualization platform you're running onto Scale, and if you try it and you don't like it, we'll migrate you back. So it's a very easy way to handle that. You guys probably recognize a few of these names, some you may or may not. This particular slide deck is not specific to North Carolina, but we definitely have several customers here. And this one's hard to see, given how dark it's showing up, but I do have that same thing on a data sheet here. So this is the product data sheet. If you stop by our booth, we have a lot of these. I have a couple in my hand, and you're welcome to the ones I have, but if you'll stop by our booth, I've got a whole stack of these. And there is also a guide to hyperconvergence for small to mid-sized organizations, and we have several of these at the booth as well too. So if you want to stop by, I can give you some information on that. If what we presented today looks interesting to you, we'd be happy to do a follow-up call with you. We have a performance monitoring system that helps to understand the performance consumption of your current environment, how many CPUs are being used, how much RAM is being used, how much IOPS are being consumed in your current environment. And from that report, it's a free tool, and from that report, we can size specifically a config of HC3 that would be a good fit for your environment. And we generally give folks kind of a option A and option B. Option A might be sort of spot on what they're looking at, and option B might be, well, hey, if I got more storage capacity, what would that look like? Or what if I got more performance, more SSDs instead of fewer? What would that look like? How would that change my price? And just to give you another update, sort of talking to that whole we take care of our customers perspective, we launched some of the features around the hybrid tiering functionality that Shane showed earlier this year. And with that, we made available to our existing customers the opportunity to gain more value out of their existing infrastructure by doing a retrofit service. So rather than buying new nodes from us that had this functionality, we offered a retrofit service where we would go in and add SSD environment and the tiering functionality to their existing hardware without them having to go buy new stuff. So, you know, we really do try to take care of those customers and make sure that they're getting the latest and the greatest, even if what they bought was 4 or 5 years ago. So it's pretty cool stuff. Well, guys, thank you so much for your time. We really appreciate it. And stop by the booth. We'll hand out these if you want one of these down. You know, I've got a couple up here, so let me know.